Thanks for watching the 8th edition of AI Weekly Update from Henry AI Labs. This has been a really exciting week in AI with the release of PyTorch 1.3, coming with all sorts of new tools, libraries, support for things like mobile deployment, quantization, and then changes to the front-end interface covered throughout the rest of this video. We'll also look at Google's ROBEL robotics benchmark, a benchmark encouraging reproducibility on real-world physical robots, testing reinforcement learning on real-world robots compared to simulations like OpenAI Gym or DeepMind Control. We'll also look at NVIDIA's startup incubator Inception is going to be presenting their research and the technology they're building at the GTC conference. Following this introduction video is going to be a quick overview of all the AI news that we're covering in this video, and then we'll get into the details of it. Please subscribe to Henry AI Labs for more deep learning and AI videos. The headline story this week is the release of PyTorch 1.3, adding support for mobile deployment, IoT, edge device deployment, privacy libraries, quantization, name tensors change to the front-end interface, the Tektron 2 library, and many other things covered in the video. Then we'll look at this publication from The Gradient, comparing PyTorch and Tensorflow, giving some useful data and insights into the two frameworks. Then we'll look at this GitHub repository from the Allen Institute of Artificial Intelligence, showcasing using the new cloud TPU training support for PyTorch for language models and benchmarking PyTorch and TensorFlow on training on the cloud TPUs. Then we'll look at the Inception incubator program from NVIDIA, some of the talks and the companies that they're presenting at the GTC conference in Washington, D.C. Then we'll look at this model from Microsoft's research lab that is unifying visual question answering and image captioning to achieve state-of-the-art results. Then we'll look at the ROBEL robotics benchmark from Google's AI blog, a reproducibility benchmark for real-world physical robots for reinforcement learning algorithms. Then we'll look at Tektron 2, a PyTorch library that implements and has a framework for iterating on really exciting computer vision technology like pose estimation, object localization, and then semantic segmentation. Then we'll look at this article from Adrian Rosebrock at PyImageSearch comparing the Rectified Adam optimizer to the original Adam optimizer. Then from this blog post from Uber Engineering, looking at how to construct datasets to query edge cases in self-driving car datasets. Then from Uber, we'll look at their use of the Presto open source distributed SQL query engine. From NVIDIA, we'll cover the top 5 AI developer stories of the week that they've published. Their automatic high beam control using computer vision and deep learning to automatically control high beams so as not to blind the car that's coming in the opposite direction of the high beam. Then we'll look at the latest updates to the NVIDIA CUDA-X libraries. Really exciting things like neural modules, Tensor RT6, and the NGC containers. Then from weights and biases, we'll look at 6 ways to debug a machine learning model and show how you can use the weights and biases interface to improve your models. From DeepMind, they've released their BigBiGAN Pre-trained models, and we'll discuss what this is and a collab notebook to help you get started with this kind of model. Then we'll cover TheBatch, the weekly roundup from Andrew Ang at deeplearning.ai. The recent story in artificial intelligence lately has been the battle of machine learning frameworks between the release of TensorFlow 2.0 and now the release of PyTorch 1.3. So PyTorch 1.3 coming with a complimentary developer conference where you can watch talks and presentations about some of the new features in the PyTorch 1.3 framework. Primarily the main features are the support for mobile deployment, a quantization library, the name tensors to clean up the code and make the code more readable, and then some interesting libraries like Captum and Tektron 2, and then the fair sequence model. So interestingly is the growth of PyTorch. PyTorch citations on archive has grown 194% just in the first half of 2019 alone, more than 50% growth in the number of contributors to the platform, reaching nearly 1,200 developers working on PyTorch. So PyTorch 1.3, a really cool feature is this name tensors. So if you've done something like ResNet, where you add tensors along this like feature dimension, you might just use something like dimension equals 1. And this syntax of passing in the dimensions where you're doing these kinds of operations on intermediate tensors and neural networks is sort of confusing. It makes the code not very readable. But compared to this, now we're using the named tensor framework, where you have these names for each specific axis of the tensor. So you see something like images.sum, channel axis. It's just much more readable, and it makes it easier for researchers, developers to kind of share code and understand what everyone is trying to do. Following this is the quantization library announced by PyTorch. So this is an 8-bit integer quantization. They have a blog post detailing what quantization is, reducing the precision of the data types, and it doesn't result in too much accuracy loss, but dramatically speeds up inference, reduces storage cost, computation costs. And then they have an example of implementing dynamic quantization on an LSTM word language model. Particularly step 4 of this tutorial is where you test the dynamic quantization. The update to PyTorch 1.3 also features the deployment to mobile, deployment on edge devices, and then you can see an exact tutorial on PyTorch Mobile taking you through iOS and Android deployment, particularly with these PyTorch models. So then also there's a lot of tools, libraries. Captum is really interesting. It's like you can see which pixels attributed the most to the prediction on this pre-trained ResNet 50 image classifier that probably classified this as dog. And then you can see the visualization, model interpretability, this kind of idea. Crypt10 is this encryption framework. I'm not super knowledgeable about it, but there's a lot of links in the post that you can go check it out if you know more about this. Then multimodal AI systems, particularly modality between language and vision in Detectron 2. Things like object detection, where you're bridging language and vision by doing the bounding boxes and then assigning like a language token label to it. And then FairSeek, where you are combining language and then audio processing for automatic speech recognition. Also really interestingly is that the PyTorch library now supports training on the cloud TPU pods, something I've seen a lot of news about as well. And then a lot of interesting projects in PyTorch. The Mila Speech Brain project, Spacey, obviously Hugging Face PyTorch transformers, and then the PyTorch Lightning, which is a Keras-like ML library. So really interesting announcements, a lot of cool new features with PyTorch 1.3, and then just interesting to watch the debate between PyTorch and then TensorFlow. The Gradient has a great blog post that kind of gives some of the data to provide more insight into the debate between the TensorFlow 2.0 release and the PyTorch 1.3 release, which has been having a lot of Twitter debates, Francois Chalet arguing on behalf of Keras and TensorFlow, and Jeremy Howard arguing on behalf of fast AI built on top of PyTorch. So all this debate between the machine learning frameworks, PyTorch and TensorFlow, this article definitely helps to put it into perspective. So one of the interesting things is just the growth of PyTorch. Cited also the 194% increase in archive mentions in PyTorch in just the first half of 2019. These kinds of this data shown in this blog post definitely shows this trend in more detail. So you can see that the PyTorch growth from 2018 to 2019 all basically exceeds 200% in all the major CVPR, NAACL, ACL, ICLR, ICML, whereas the TensorFlow is actually like declining in citations in 3 out of these 5 conferences. And then generally just the growth comparison is really outrageously different. And you see generally PyTorch is achieving more citations than TensorFlow just 1 year later. So in the article they discuss, researchers love PyTorch. The research community is more drawn towards PyTorch than TensorFlow. Particularly they say things like the simplicity of it, the API of PyTorch to TensorFlow, and then the performance of PyTorch, is cited to be as fast, if not faster, than TensorFlow. So generally the article then goes on to talk about sort of, the implication of one framework over the other. If all the models are implemented in PyTorch, you're going to be more likely to use PyTorch just because a lot of deep learning research is in this direction where you go and you look for a pre-trained, say, language model like the, Hugging Face transformers. And so you're going to adapt that into the framework that it's implemented in. So there is a lot of great insights in this article. I definitely recommend checking it out from the Gradient publication. A really interesting update to PyTorch and PyTorch 1.3 is the support of training on cloud TPUs. Cloud TPUs are these accelerators developed at Google, different from the GPU. The TPU is supposed to be faster, and now the PyTorch models can be trained using the Google Cloud TPUs. So this repository from the Allen Institute of Artificial Intelligence shows you some benchmarks for language model pre-training with PyTorch Cloud TPUs, and then some instructions for how you can do this yourself. So the README starts with how to set up the Cloud TPU, how to set up your PyTorch environment on it, and then this language model pre-training repository that they're using to benchmark this. And then finally they report this benchmark, PyTorch versus TensorFlow, the V100 GPU or the set of 8 V100 GPUs compared with the Cloud TPU pods, and then different batch sizes that you're using to train the models. So you see that the PyTorch models are being trained slightly faster than with the 8 V100s, but they still aren't quite as fast as TensorFlow on the TPU V38 Cloud Pod TPUs. So you see that this kind of acceleration still isn't there yet, but the author of the README suggests that switching to this MP interface should reduce the gap. But it's not something I'm super familiar with, so definitely check it out if you're interested. NVIDIA's startup incubator Inception will be hosting sort of a Y Combinator demo day-like showcase of their startups that are doing tons of interesting work using GPU technology and artificial intelligence. So first on this list is No Traffic, using computer vision to help optimize traffic lights. You can check up their website, notraffic.tech. All sorts of interesting things with IoT, computer vision on the edge. Following this is Iguazio. Iguazio is a data science platform as a service. You can check it out. They have a documentation overview on how to get started using it. Following this is CrowdAI, which is this really interesting technology using satellite data to provide more information about road networks, particularly in the case of like a natural disaster or something like that. Then is Vyasa Analytics, really exciting startup using things like BER and different AI models with their Cortex product and this LAR in order to get more data out of different kinds of life sciences, healthcare, legal, business intelligence, and marketing data sets. And then is the Blazing SQL engine, something that's optimized their SQL and their Rapids library with NVIDIA. And then Kinetica, another really interesting platform service. And then you can check out all the websites for the different startups in the NVIDIA Inception incubator program. Definitely going to be an interesting kind of presentation. Microsoft's research blog has published a really interesting framework for pre-training language models that do visual question answering, where you're given a scene and you ask questions to the model like, are the people in the image dressed the same? And then you would answer yes or no, or something like, is there an umbrella in the picture, would be an example of visual question answering. And then you're combining the model to do this visual question answering with image captioning. So this kind of multitask learning is interesting, definitely interesting to think about, what kind of tasks fit together. In this case, it looks like the relationship between visual question answering and image captioning provides a really nice, unified representation learning framework. So they use this unified encoder-decoder with a, transformer architecture. You can read more details specifically about how the model works in their research paper. Things like they're using a pre-trained, region proposal kind of object detection network to, extract the features from the image. Well, there's definitely a lot of details to get into with this VLP pre-training model, but generally you can see the results that they're, achieving higher performance than specific models on the MS Coco captions, the Flickr 30 captions, and then the visual question answering 2.0 benchmark. So it's definitely a really interesting example of multitask learning a shared representation through doing both these tasks at the same time. Google's AI blog has released a really exciting robotics benchmark for real-world physical robots, instructions on how to reproduce and construct these robots so that you can benchmark different reinforcement learning algorithms. So currently most of these reinforcement learning algorithms are tested in these simulated environments like DeepMind Control or OpenAI Gym. So OpenAI Gym has these different simulated environments like balancing a cart pole, getting the mountain car up the hill, things like bipedal walker, Atari games, and then more advanced robotics like where you rotate the cube in your hand. And all these environments share the same interface of the OpenAI Gym, where you have the env equals gym.make, and then you put in the particular problem that you'd like to experiment with, and then you have this interface of giving the environment an action and then receiving a next state and next reward from the environment. And this is the general framework for all reinforcement learning problems. So the ROBEL also fits into this software framework defined by OpenAI Gym, but contrary to physical hardware systems that are usually on high quality industrial robotics, this is a system for producing real physical robots that aren't too expensive. The ROBEL benchmark particularly defines these two different robots, the D-Kitty, which is the four-legged walking style robot, and then the D-Claw, which is these things like dexterous manipulation and tasks like rotating the nozzle. So what they have is they have instructions on how to put together these robots. So you go to something like the ROBEL platforms, and then if you want to put together the D-Claw, you click on D-Claw files. It'll give you all the things you need, like the motors that you have to buy, even though they can be a little expensive, and then things like the STL files to 3D print other parts. Then they'll give you the assembly instructions to put together the D-Claw. And then you interface it using their software. The formal research paper, ROBEL, Robotics Benchmarks for Learning with Low-Cost Robots, has more details particularly about the benchmarks and the robots themselves, how well the reinforcement learning agents perform on them. So you see that they're a little expensive, ranging between $3,500 for the D-Claw and $4,200 for the D-Kitty. So it's not quite super low cost, although it's low cost relative to the other physical robots that are out there. So also in this paper you can see the agent environment interface and how they're structuring these kinds of tasks, and then you can see the performance that they achieve with the different algorithms like the soft actor critic, natural policy gradients, and then the DAPG, other kinds of algorithms. So then you can also see this gallery where you can watch videos of these robots and see how they're performing, see kind of what this looks like. With the release of PyTorch 1.3, Facebook released Detectron 2, a PyTorch-based modular object detection library, and this is definitely the most popular library, most powerful library out there for things like object localization, where you are drawing this bounding box around images and then giving them some kind of class label. things like pose estimation, semantic segmentation are all going to be much easier to get up and started with using this Detectron 2 library on PyTorch. So in this video, you see things like this is the object localization where they're classifying, laptop, pot, refrigerator, things like that. And the video shows this pose estimation, then these semantic segmentation masks, and then just taking it to the next level and having this really multi-label kind of semantic segmentation task. So the Detectron 2 has this extensibility where you can replace the backbone and then classification heads. So generally the way these like mask RCNN and these kind of models is they have some kind of feature extractor like a ResNet, then they might have like a region proposal network or something like this, and then they would classify the regions that have been proposed. That would be how something like an object localization model would work, or even something similar is probably how pose estimation and these kinds of things work, like dense pose and the semantic segmentation head they're describing here. So generally, it's a really interesting library, definitely going to make it easier for people to get started using these advanced computer vision technologies. Adrian Rosebrock, the founder of PyImageSearch, who makes tons of great tutorials on computer vision and particularly using computer vision on the Raspberry Pi and the NVIDIA Jetson devices, published this great article, Is Rectified Adam Actually Better Than Adam? So this is a really interesting article. I was really excited to read this because I've seen a lot of recommendations to read this paper on the Rectified Adam optimizer. So in the article, he describes the modifications to the Adam optimizer that makes it the Rectified Adam, applying warm-up with a low initial learning rate, and then simply turning off the momentum term for the first few sets of input training batches. So this paper on the variance of adaptive learning rate and beyond, the Rectified Adam optimizer, has received a lot of attention. And in this blog post, Adrian is going to benchmark the Adam versus Rectified Adam using ResNet, GoogleNet, MiniVGGNet, and then on these different datasets, MNIST, Fashion MNIST, CFAR10, and CFAR100. So in this blog post, you can see, the setting up, the experiments, a lot of the code involved with this. But then if you, go down to the results, you see generally though, just to summarize it, generally he sees that, the Adam optimizer tends to crush the Rectified Adam optimizer. The Rectified Adam optimizer doesn't achieve better performance in any of the cases that he tests. Also from Uber's engineering blog is a really interesting article about a data set for querying uncommon scenarios in self-driving car development. So using things like the Hadoop distributed file system, Hive, Spark, they're talking about how they can process this video data, which is the streams of frames which becomes the self-driving car data sets, and how they can structure it into this data set such that you can search it, it's dependable, durable, scalable, and you can make these kind of queries in the database and have these kinds of visualizations of the edge cases in the self-driving car training data. Definitely a really interesting article, a lot of interesting data visualization tools being developed to facilitate the advancement of self-driving cars. From Uber's engineering blog is a discussion of how they use the open source Presto distributed SQL query engine in Uber and some of the different testimonials for ways in which like Presto helps them out and sort of to motivate you to check out Presto and use it for your data analytics needs. You can see in this article are different testimonials. This is an example of like a case where he was able to optimize the query, SQL query, using this kind of like ordering and like the relational algebra SQL engine, where you do the rank function before you get the data. And then it goes on to tell some of the favorite things about his use with Presto. And then there are a lot of other engineers at Uber using this Presto, telling you about why they like using it to motivate you to maybe check it out. NVIDIA has published its top 5 AI developer stories of the week. At 5 is the Skydio 2 drone. We looked at this I think a couple weeks ago. It's a drone that has these NVIDIA Jetson TX2 processors, able to track up to 10 objects at a time while traveling at 36 miles an hour. It can fly for 23 minutes at a time. Definitely really interesting autopilot with the drone and the ability to track objects. At 4 is the MIT Lincoln Laboratory. This has 896 NVIDIA Tensor Core V100 GPUs. Just amazing supercomputer, amazing GPU, assembly of the computer. Then at 3 is the Jetson Nano competition at the Booz Allen Summer Games. You can check this out, the Project Razor, a autonomous ground vehicle, which is using the NVIDIA Jetson Nano for the on-device processing of the, the deep learning inference. At 2 is the entrepreneur brings GPU to fashion, something that we've covered about the AI digital assistants used to suggest changes in outfits. And then at 1 is the NVIDIA RTX broadcast engine, a really cool example integrating a lot of these cool AI features. Things like style transfer, using the AR to have the face mesh and then mask it to an animated character. You can see the style transfer, and then you can see this really cool, the face mesh being transferred onto this animated character. NVIDIA released a blog post updating some of the latest changes to the NVIDIA CUDA-X library. So this is a lot of what runs under the hood with the GPU accelerators. So the neural modules is an API for assembling neural networks, particularly for automatic speech recognition and natural language processing. You can check out their tutorials. TensorRT inference accelerator, able to achieve 5.8 milliseconds inference with the BERT large model. Also tons of accelerations for conversational AI, ASR, and then particularly a lot for these like 3D convolutions and these image segmentation applications. So then the CUDNN 7.6 library, again with the tensor core being improved with the support for 3D convolutions, and then the multi-head attention, training, and inference times. The NGC containers. You can see a really cool example implementing the Jasper model, which is this ASR system, convolutional ASR. You see the model architecture, and then they'll take you through the NGC containers that you can use to accelerate the training of this model. So then the TensorRT inference server, bringing the things like the TensorRT integration, the inference accelerator, bringing this to the server in different ways with the deploying PyTorch models, host models in AWS S3 model repository. A lot of interesting stuff advancing the CUDA-X library. NVIDIA has posted a really interesting use of deep neural network technology for adaptive high beam lights. So the way that this works is it has the neural network processing the computer vision type of thing to see the car coming, and then it's able to adapt the high beam such that it doesn't like blind the car that's driving past you, and then turn the high beam back on. So it's really interesting sort of way of optimizing cars and just making the road safer using computer vision and deep learning. Weights and Bias published an interesting article about 6 ways to debug a machine learning model. So the list is the 6 things are how to find your flaws in your input data, make the model learn more from less data, how to prepare your data, things like min-max scaling and normalization, how to find the optimal model hyperparameters, particularly using the weights and biases hyperparameter visualization, and then how to schedule learning rates and how to monitor training progress with weights and biases. So 1, finding the flaws in the input data. Does your data, can it predict what you want it to predict? And then do you have enough data? The next thing is how to make the model learn more for less data. A comparison on the success of using pre-trained models. If you have this kind of access, using transfer learning and pre-trained models may help you, achieve more with less data, as well as using data augmentation. Then talk about normalization, standardization, min-max rescaling, and mean normalization, just to pre-process the data and make it suitable for the neural networks. And then how to find the optimal hyperparameters, a link to this mask RCNN example where they use these kind of weights and biases visualization to go through different learning rates and achieve better performance this way. Then they talk about learning rate annealing, this kind of idea. And then overall a little tutorial on how to use weights and biases. You import it, init it, set up the configuration, and then just attach it to your training with the weights and biases.log, this kind of interface. And then it will help you track your hyperparameters and the performance of your model. DeepMind has released pre-trained BigBiGAN representation learning models, which is really interesting. This BigBiGAN model is this idea of using the generative adversarial network framework to not only generate images, but also to learn useful representations or features of images by having this forwards and backwards mapping between the encoder and the generator. So the encoder and the latent, they form these different pairs where you have the latent is like this vector sampled from some distribution that the generative adversarial network, the generator component, transforms into an image. But now the generator is tasked with transforming it into an image and then reconstructing the latent code that it was, sourced from. And then it will do this with, original images from the training data set as well. And hopefully this will help to, learn good features. Representation learning is kind of the big idea of deep learning, especially computer vision. And so what they've done with DeepMind is they're releasing these pre-trained BigBiGAN models that you can use. They have the Collab notebook where you can go through things. You can test with, encoding the images with the encoder model and then generating them with different latents, or even doing the mapping of taking an image, encoding it, and then, decoding it with the generator. This week's edition of TheBatch begins with commentary from Andrew Ng about a controversial research paper, Read, Attend, and Comment, which is a transformer architecture for automatically generating comments on articles, blog posts, these kinds of things. So it could definitely be like a tool to just add noise to the media environment, as Andrew Ng puts it. Things like the stage release of OpenAI's GPT-2 language model, and then the rise of deepfakes and these kind of things are definitely more attention needs to be placed on these kinds of attention towards generative AI models. Following this is news about Tesla's acquisition of DeepScale. DeepScale is a company that is using the SqueezeNet architecture developed by Forrest Iandola, where you have these squeeze and expand convolutional architecture design in order to have these really efficient convolutional neural networks. Particularly, the batch cites that they have this imposed computational budget of 0.6 trillion operations per second, which is much smaller than the operations per second that can be supported on Tesla's custom chipset. A lot of interesting details about what DeepScale is and links to go check out more about this kind of technology. Following this is a discussion about the Sup.ai, which was covered in a previous weekly update video. Sup.ai scours these thousands of papers and looks for these named entity recognition that finds similarities or interaction effects between drugs and supplements, because there's not a lot of regulation going on between these supplement to drug interactions. And the Sup.ai website tool uses natural language processing to help you scour this research and understand what kind of interactions have been discovered. Following this is this release of a digital identification program that uses facial recognition. Some controversy surrounding this, and regulation around, is this ethical? Is it violating our privacy to do this facial recognition kind of system? Next is a discussion of this framework for robotics for imitation learning and this virtual reality interface by Toyota Research Institute, where you can put on the virtual reality, control the controllers, and show the robot how to do a task, and then this robot is able to generalize into different physical environments through this interface. It's definitely a really, really interesting research piece. Not too much on the real details of how this works though yet. Following this is a discussion on the differential skin diagnosis, something we covered a while ago on Weekly Update, where you have this combination of the images and then metadata to classify many different types of skin ailments aside from just malignant benign tumors and this kind of skin cancer detection. It's more of a differential skin diagnosis system. So there is a research paper released that has more details about the system and how it works. It's got the Inception v4 architectures combining the metadata features. Really interesting article paper, as well as exceeding the performance of dermatologists. Also covered in the batch is a discussion on the acquisition of AI startups and this trend showing that with the general takeaway discussed from the batch is that this kind of shows that the AI technology is having increased application and use indicated by these acquisition trends. Thank you so much for watching the 8th edition of Artificial Intelligence Weekly Update. If there are any AI news covered in this interval between, say, October 5th to October 13th that haven't been included in this video, please leave a link to it in the comment or some kind of description of it so that these videos can be improved in the future. Thanks again for watching. Please subscribe to Henry AI Labs for more deep learning and AI videos.